geometric series. Remember what a geometric sequence is?
Yeah.
Give me an example, Lalo.
2, 4, 8.
8. That's right. 16. 32.
4.
Okay, that's a sequence, which is a list of numbers. This is what you start with. And what do you multiply by, Mariah? How do you get from 2 to 4?
You multiply 2.
Okay, and that's called the common ratio, right here. Common ratio can be negative. You can have it alternate in sign. If you had a negative 2, if you started with 2 and then you multiply by a negative 2, sorry, I didn't write that very well, that would be negative 4. What would be the next one? Negative 2 times negative 4 is positive 8. Times the negative 2 is minus 16. That's okay. That is not okay with an exponential function, which looks like this. And some of you did not take notes on this yesterday. I gave you points, but you really need to identify what's what. Okay? What do you call A? No. Starts with S. Start. It's your starting value. These worksheets aren't that bad to do. They will not take the whole time. If I get to my lesson, and you have to ask me if you don't understand something, and why is it a starting value? And while we're here, let's review a little bit about domain. What can X be? Anything. Remember, that's the domain. Those are your inputs. I don't think that's going to be on this exam. I'm not sure. But anyway, yeah, they can be decimals. They can be positive, negatives, any number. Now, here's the number that can't be negative. It's that B. And I don't really have, can I move any of this stuff? No. B itself cannot be negative. The common ratio, this is a graph of a function. This looks like this. The sequence is just a list of numbers. That one, yeah. Okay, not right now. Okay, Lalo? A sequence are a list of numbers that will sit on that curve, but they're not the same things. And when you take a geometric sequence, the function that would model that is this exponential function. Now that's a little calc too. Now B has to be positive, can't be 0, that doesn't make sense. And the other number B can't be is 1. Now why is that? Let's put it in and see. It's A times 1 to the X. What's 1 to any number?
1.
So it's Y equals A. That's not an exponential function. Does anybody remember what that looks like?
Yeah.
It's a horizontal line. That's not exponential. So this is not quite correct. Notice they did say a whole number. Guess what? B can be a decimal. It can even be pi. It could even be irrational. So I'm going to cross this out because that's not a correct statement. So that's the conditions. And if you look in any higher algebra book, they will all say the same thing. So I had to look it up. B cannot be a negative number. And you could try graphing it on a graphing calculator, putting in a negative 2 here, and you get crazy behavior. It looks crazy if it will even graph it. Okay. The common ratio will be the B in your exponential functions. That's true. Now we're going to find a percent increase. So I want to know how something's increasing. So let's go to the next slide. And I want to write this out mathematically correct. Here's my common ratio. So if my number is 1, the next number would be 1 times 1.34. I can do that one. Right? So that's 1.34. Then what are you going to do? You're going to take 1.34 and multiply it by 1.34. Now I'm stuck. Now I got to use a calculator. Well, it's 1 something, I think. It might be 2. Who's got a calculator?
No.
I don't know what it is. Okay, 13 times 13 would be 169. So 1.6, it'll be bigger. What is it?
1.80.
Exactly?
No, it's 1.79, but I just...
It's 1 point what?
79.
Exactly?
Yeah.
Okay. No, because sometimes I need those places. Yeah. Oh, 7956. Okay, to get the next one, absolutely I want a calculator. No question about it. So the question is, what's the increase? To find your percent increase, you take this common ratio, 1.34. Talked about a ratio and I wrote R. 1.34, and you subtract from 1. I want to see how much bigger than 1 is. If you multiply by 1, there's no increase. Like Mariah says, I'll just get a straight line. There's no increase. So that's my increase, which is what? 0.34. So that should be kind of easy. And do you remember how to change any decimal to a percent? Because if this b value is bigger than 1, we get an increase. If b is bigger than 0, whoops, wrote that wrong. And that's very wrong, by the way. If b is bigger than 0 but smaller than 1, so it's a fraction, like 1/2, should we do that? That one? You're going to get a decrease. So the question is, how much does it increase? So you compare it to 1. Right. How do you change? So I take 1 point, whatever the R is, so it's R minus 1. How do you change any number to a percent? This is a life skill now. You multiply by what? Well, you're right, Caitlin, up to a point. Not just 100, because if I multiply by 100, it's 100 times bigger. That's not the same as 0.34, is it? Is 34 equal to 0.34? Lalo?
Yeah.
You got a choice, 34 cents or $34. Which do you want?
$34.
It's not the same. So the only way to make this work is to make that 100%. Because what's 100% equal to? 1. This is a nice little trick. I don't care if it's a fraction or what it is. You multiply it by 100%. This gives me 34, and that percent sign has not been used, so it's still there. 34%. Some of you like to say, well, multiplying by that just moves the decimal over 2 places. That's fine. That's just a little trick or rule. I don't like it. Okay, well, the problem is, what about this one? What is my percent increase? So you take 3.12 and you subtract 1 from it. 2.12. And now I want to change it to a percent. I don't care what it is, Joe. Joe, phone's away. We are going to, I'm sorry, what? Sure. Yeah, if I go too fast, let me know. It's not meant to be long or hard. You have plenty of time to work on it or make up assessments if you're missing assessments. But if you're not ready for your assessment, then you shouldn't do that. But I made a list of all of them so I know who you are. Okay, ready? How do you change it to percent? Just multiply by 100% because this equals 1. And if you know why things are next year, when somebody jogs your memory, it's going to be fine. You're going to be great. Okay, so you can put it on your calculator if you want, but what does 100 do to that decimal? It moves over 2 places. So it's 212%, which is a fabulous growth. The stock market is growing like that too, by the way. I always want to know what my percent increase is. And that's all you do. You take your ratio, subtract 1. If it were a decrease, you'd still take your ratio and subtract 1. It'll be negative because there's a decrease. I think we're only doing increases here. Now it gets a little trickier. Okay, Mariah? We're going to fill a bathtub, and it's increasing in water 15% each minute. So if we reverse it, I know what the increase is. Yeah. So there's your decimal, 0.15. So I'm going to change it. If you want to think of a rule to do it, you take 15% and you divide by 100%. So it's the same as this, 15% over 100%. What happens to the percent symbols? They cancel, don't they? And 15 over 100 written in decimal form. We didn't review this. This old math. Do you remember what that is, Cole? 15 divided by 100? What do these zeros make this decimal do? Makes it move that way. So this is equal to 0.15. That's how much things are bigger than our, if you want to call it equilibrium value, which is 1. But this is above 1, remember? These are the ones that are not increasing at all. If they're going to increase, it's going to do that, right? So what do you think you have to do with this? I'm reversing the process before we subtracted 1. That's right. So it's 1.15. Britt, is that what you're going to say? Sorry. So if you're given the R, to get the percent of increase, you go R minus 1, and you multiply by 100%. That gives you the percent increase. To reverse it, it'll be not R, it'll be the percent divided by 100%, and you'll add 1 if you want a little rule. But you can use notes, so rules in this case aren't bad. How often am I using this? Maybe. Maybe I want an exponential function. This is exponential growth. Okay, Mariah, I'm almost done. Pretty sure I'm almost done. Okay, here's a deer population. And they've been using this stuff all the time. What do they do in Minnesota, northern Minnesota? They reintroduce the wolf, right? Yeah. And the moose population is declining, which is not a good thing because now we don't have moose. Okay, actually we have 2 problems left to do. Or is it meese? Sorry. What's the plural of moose? What? What's the plural of moose? Moose. That's what I said. Was meese. So what's the plural of sheep? Sheep. So you want a funny little story with Ahmed? Because we were going down and looking at all the pyramids, and they have these walkways, and there are sheep, but they're not 100% formed anymore because of all the time. And I'm looking at him, he keeps talking about the sheeps. And I thought he was talking about ships. And I go, there are no ships here. But he was trying to talk about the sheep, and he didn't know the plural of sheep is sheep. I kept talking about the sheeps. So he does that quite a bit. I thought it was pretty funny. Because I thought he was talking about ships. Well, that's the problem when you talk in a different language, as Lalo knows, right? It's very easy to mess it up. Okay, so in northern Minnesota, well, they have a deer population that's huge here. That's why they allow hunting. And now they're hunting the wolf. So the population is increasing at a rate of 8% every year. What's the percent increase? There's a way to think about it. It's what? Remember, this is, okay, that's 0.08. And then what do you have to do? You have to add what to it? 1. So you're going to add this. You're going to change this to a decimal, basically, and add 1. So it's 1.08. What's the starting value? It's up here. It's in the problem. 670. What's the common ratio? Actually, I didn't write that right. The percent increase is 8%. Okay, this is what goes here. Common ratio is 1.08. And you guys know what the equation looks like? What do you want to call the deer population? D? D. D is equal to your starting value. How about I put it in words? Times your common ratio. In this case, it's to the time, or X, depending on what you want to do it. So the deer population, Suzanne, what are we going to start with? What are we starting with? How many deer are there? Or wolves? 670. Then what's my ratio? 1 point, not 8, but close. 1.08. And what's the other variable? It's a T. That's growing 8% a year. What's going to happen if the deer population continues to grow at 8% a year? There's going to be a lot of deer. What's going to happen? What does happen to them? Why do we allow hunting? They starve because we don't have enough resources. So then we allow the hunters in there, and guess what happens to your population? It does this, and then it may actually go over this value and then levels off. It's called a carrying capacity. And it's a problem in the whole world. And I can talk about Egypt, China, like Shanghai. What do they have in Shanghai? 25 million?
They have a lot.
How big is New York City?
Like,
I think it's about 14 million.
wow.
Pretty close. It's good size. Alexandria is 16 million. Cairo is 20 million. And the size of Egypt is probably not much bigger than Minnesota. I really should compare them. 90 million people. Do you know how many millions we have here? 3. Their population is almost 90 times bigger than ours. That means there's a lot of people everywhere. Joe, put your phone away. Joe's going to do this problem for us because he knows how to do it. Joe puts, there we go, $1,600 in a bank account. Which I have $1,600. But anyway, it increases at a rate of 11%. Lucas is going to help you. Find the following. What's the percent increase? 11%. Okay, you guys, write it down. See if you can beat us to doing the problem. It's the last one. The worksheet looks just like this. So if you can't do this, you can't do the worksheet. Alex, what's our starting value? How much money do you have to begin with? Don't we all wish? Okay, the common ratio. This is equal to, in a decimal, 0.11, right? Then what do you do with this number? You take 0.11 and you add 1. But we're going to go backwards and forwards. Yes. 1.11. Now, does anybody have the equation?
Money sign.
Okay, I like that. Is your starting value. Do you want me to write it in words again, Britt?
Start on 1,600. Parentheses 1.11.
To the t. I use t for time. But you can use x. You can say y equals 1,600, 1.11x. You can do that. Now, you might want to keep your notes with you when you do the worksheet. First thing you should do is finish up yesterday's worksheet. Are there questions on that? And if I didn't get yesterday's packet, I should get that. Yes. Kate, you don't think you need it. You think you can do it, huh? And Ray, did you finish up your quiz? Let's get that done first. And I think you can